Everyone, in today's video we are discussing about the pumping lemma theorem. So what this pumping lemma theorem will tell? It will tell that we have to prove the language is not regular. So what is our theorem? Theorem is pumping lemma theorem for proving regular language is not a regular. And pumping lemma is used to prove that language is not regular. It cannot be used to prove language is regular. It is only used to prove language is not regular. We can't prove this language is regular. Then theorem, if language is a regular language, then the language has pumping length p or n, we can say, such that any string which can be formed, that is string is what? W. So any string which is able to form from W should be greater than or equals to the pumping length, which may be divided into three parts. That is, our W string, whatever we select, it can be divided into X, Y, Z. We have to choose a string which can be divided into X, Y, Z, where X, Y raised to power I is nothing but any integer value. We can take from 0 to n number any integer value, X, Y raised to power I into Z, which belongs to language. But for some I, this language doesn't suit, that this X, Y, Z is not belonging to some I value. We'll see how in examples. Next we have the Y, that is the Y element. When we have divided our string into three parts, the Y element should be greater than 0. That is, Y cannot be empty string. It should not be empty string. And XY should be lesser than or equals to pumping length. That is, when we see our XY, it should be lesser than or equals to the pumping length, whatever value we have taken. Next, proof. To prove that language is not regular using pumping lemma, we follow the following steps. Assume that L is a language which is regular and it has to have a pumping length, we can say P, or we can say any N or any alphabet. All string larger than P can be pumped. That is, the string can be greater than or equals to pumping length. Now find a string W in L such that mod of W is greater than or equals to P and W can be divided into X, Y, Z. So we have to choose a string which can be divided into X, Y, Z. So here the next step is show that X, Y raised to power I into Z, that will not belong to language for some I. It is saying that it is not for all the integer value. For some integer value, this string whatever we have chosen, when we are proving this alphabet X into Y raised to power I into Z, it should not belongs to the language. Then consider all ways that W can be divided into X, Y, Z. Show that none of these can satisfy all three pumping condition at the same time. When we prove that all these three cannot be satisfied at the same time, we can say W cannot be pumped.